Here's a video comparing and explaining the formulas for linear growth and exponential growth. And so I wanted to show you, so generally the formula for linear growth, the point slope formula for linear growth, you talk about the increasing by a certain amount, the rise, every run year. So every time you increase the x value by the run, you go up by the rise as adding that amount. And so the formula is often written as something like this: y equals y1 plus the slope times x minus x1. And one of the things with algebra that I want to show you is you could very well put the run over here, and I'll explain exactly why you might want to do that to compare it to the exponential form in just a second. The exponential growth, the difference there is you're multiplying by some growth factor every so often. So you have the same run, the horizontal change, and every period you multiply by something. You don't add something, but you multiply by something. You multiply by the growth factor. And so the formula then ends up being very similar. The starting value, y1, times what you multiply by, and the exponent is how many times you multiply. So when you multiply over and over again, you get an exponent. When you add over and over again up here, you multiply. So that's the similarities and the distinctions. So let's do an example. So I've got a linear growth, and suppose I have a chart that shows my sales over certain years. So in the second year, I had 200, maybe it's 200,000, 200 in sales. And by the 10th year, I was up to 600 in sales. So I want to know a formula for that. So I can talk about the periodic rise, and what that means, the way to describe this chart is my sales increased by $400, and it took 8 years to do that. And so if I assume that rate is constant, every 8 years, my sales increase by $400. So that's the way I can describe that growth. So I get a formula that says I start with 200 at my starting point of 2 years. At time 2, I had 200 in sales, and I go up by this rise every 8-year period. So what I multiply by here is the number of 8-year periods after I start at 2. So from 2 to x, I take the difference and I divide it up into 8-year chunks, and that product that in parentheses there is how many 8-year periods there are. And so I can write down the formula. What happens though if I want to change the period? I can use algebra to notice that $400 in 8 years is the same as $200 in 4 years. On a chart, what that means is I'm doing the green stair steps instead. So I go over 2 years and I go up $200. I go over another 2 years, I go up another $200. And so I get a linear growth, and I can change what my period is, how wide my stair steps are. I can either go over 8 years and up 400, or I can go over, these should be 4s. Sorry, over 4 years up 200, over 4 years up 200. So I can change the width of my stair steps. And it's just algebra to simplify 400 over 8 equals 200 over 4. And so I can change my formula. I can do that for any length of the period. And so what I have is I can change the length of the period to be I increase by a certain ratio or certain amount every 8 years, or whatever the run happens to be. And so I get a formula that looks like 200 plus the rise times x minus 2 over h. And that's the periodic rise divided by the length of the period. How do I find the y-intercept with that? I've shown you how to get the point slope formula, where you have a certain point you start at, 200, and you have a slope. Well, the y-intercept is the value when x is 0. And so if you look at this algebra, essentially what you're doing when you multiply out the slope, the point slope form, when you multiply that out, what you do is you distribute this and you get the rise times x, the rise of the run times x, and the rise of the run times 2. And if you move this, rearrange the terms, that's really saying you start at 200, but then you back up 2 years to get to times 0. And so you multiply by the slope twice and you subtract that away. And so what happens then, let's do the specific numbers we've got here. The way to think about this form is you got 200 and I 200 and I go up by 50 every time how far past 2 I am. Well, if I'm back at 0, I have to go back another minus 2, so that is minus 2 times 50. So I go down 100, and if I can make that into a linear equation, I get my y-intercept is 100, and so my equation is 100 plus 50x, my intercept plus the slope times x form. What happens with exponential growth? It's the exact same ideas. The only difference is instead of adding a certain amount each period, you're multiplying by a certain amount each period. You multiply by a certain amount. So let's take the same 2 points, 200 and 600. So that means that I've got, what's my growth factor? I'm not increasing by 400. What I want to consider is my growth factor is I multiply by 3. I go from 200 to 600, so I multiply by 3 every 8 years. And so I can write down a similar formula where instead of adding the rise every time, I'm multiplying by the growth factor every time. So I start with the starting value and I multiply by whatever the periodic growth factor is. So let's say it's 3 in this case. And the exponent is how many times I've multiplied by that. So it's going to be the number of years divided by the length of one period, the run. So let's try that with our concrete example. We can also then change the period. So, so what if we change the period, instead of an 8-year period, we want to do a 4-year period? Over 8 years, I multiply by 3. I have a growth factor of 3. So in half the time, I have half that factor, which isn't 3 divided by 2. It's the half root, or the half power of 3, the square root of 3. And so one way to think about that is on our chart, I can go in half the time, I go up by 3 to the 1/2 power, a half a factor of 3. And then in half the time, I go up by a factor of 3 to the half. And so I can change my way to describe the growth factor. I can say I go up by the square root of 3 every 4 years. If I do that twice, I go up by the square root of 3 times the square root of 3, which is 3 in 8 years. What if I do the same for divided into 4 2-year periods? What if I change the period from 8 years to 4 years? Then in 1/4 of the time, I multiply by the 4th root of 3. That should be a 2, every 2 years. So if I take 1/4 of the time, I take 1/4 of the factor. I don't divide 3 by 4, I take a 4th root. And what that means is I find something, and your calculator can give you an answer for what 3 to the 1/4 power means. But if every one of those red stair steps here, over 2 years, up to the 4th root of 3, over 2 years, up the 4th root of 3, over 2 years, up the 4th root of 3, and so on. And you can see that they increase faster and faster, and you get an exponential growth. So the final thing that I wanted to point out is this formula that we can do here says I've got 200 to start, and I multiply by 3 every 8 years. So I start when x is 2, I start at 200. And every so often, every 8 years, I multiply by 3. So like we did with the linear equation, we can use algebra to simplify this. The algebra for exponents means the exponent, when I divide by 8, I can put that inside and take the fractional power of 3. I can take the 1/8 factor of 3 to the 1/8. And your calculator can tell you what that is. But here's a chart that kind of describes it. Here's where I'm starting. I start in year 2. And every year I move up, I multiply by 3 to the 1/8. Then I multiply by 3 to the 1/8 again, and that's 3 to the 2/8. 3 to the 3/8, 3 to the 4/8, 3 to the 5/8. After 8 years, I'm up at 3 to the 8/8, which is just 3. So if you think about multiplying by that fractional power each time, I can change my period. I can say, every year I multiply by one of those red factors and I go up by 3 to the 1/8. If I decide to do every 2 years, I'm multiplying by these blue factors, and I'm multiplying by 3 to the 2/8 or 3 to the 1/4. And so that's 4 periods in 8 years. Or I can do the purple and say every 4 years I multiply by 3 to the 4/8, which is 3 to the 1/2, half the time. So I multiply by 3 to the 1/2. Last thing I wanted to do is you can figure out what your y-intercept would be. What happens if we have our starting point of 2 and 200. What happens when x is 0? Well, when x is 0, what you do on this chart would be, if you're going forward, you add, you multiply by another power of 3 to the 1/8. If you go backwards, you subtract in your exponent, and you get 3 to the negative 1/8 and 3 to the negative 2/8. And so what that means is if you go backwards, you're dividing by this growth factor. And so on this last chart, you can see, if you zoom down in here at the bottom in here, from my beginning, I go backwards 2 years. So I divide by 3 to the 2/8 or 3 to the 1/4, which happens to end up with 151.9. So you can get a little formula for this sort of expression, and I can revise that. Even if I don't have a starting point, if I know a point like 2 years in the future, I have my value of 200. I can find out what my starting point is by doing this subtracting in the exponent, which is the same as dividing my the constant out in front, my initial. And so I could, in the final version of this, write down a formula that goes through those 2 points, where I start when x is 0, that's like my y-intercept. And this is my growth factor, but it's my annual growth factor, because I decided to take the 8th root of my 8-year growth factor. So I hope talking through all those things clarifies and helps you get a better understanding of what these formulas are. We're going to do examples in class where we work out the problems, but this is supposed to be a way to see the connections between these formulas. I hope it helps.